Have you ever wondered what lies beyond our universe? What if I told you it could be an infinite sea of other universes? This is the concept of the multiverse, a mind-bending theory that suggests our universe may not be the only one out there. Think of it this way. Imagine you're on a ship sailing the open sea. All around you, the horizon stretches out, each one leading to new and unexplored waters. This is similar to our position in the universe. We are in our own ship, navigating the cosmos, with the potential for countless horizons, each one a different universe. Just like every sea has its own unique characteristics, each of these universes could be governed by its own set of laws and physical constants. Picture a universe where gravity is stronger or weaker, or where the speed of light is different from ours. Each universe could be as unique as a fingerprint, imprinted with its own distinct set of cosmic rules. But why do we think this could be possible? The multiverse theory is not just a product of wild imagination. It's a concept that emerged from our attempts to understand the fundamental nature of reality. It's closely linked to quantum physics and cosmic inflation, theories that have been rigorously tested and have withstood the test of time. So, just as a ship at sea is surrounded by endless horizons, our universe could be surrounded by an endless array of other universes, each one as real as our own, but perhaps wildly different in its properties and laws. But remember, we're just starting to explore this idea. We're on the deck of our ship, scanning the horizon with our telescopes, trying to make sense of what lies beyond. It's a journey of discovery that might take us to places we've never even dreamed of. So, come aboard. Let's set sail on this cosmic sea and see where the winds of science will take us. This is our journey into the multiverse, a voyage into the unknown. Are you ready? Because the sea of universes awaits us. Just as a ship at sea is surrounded by endless horizons, our universe could be surrounded by an endless array of other universes. Now, you might be asking, why do scientists believe in the multiverse? Well, the concept of the multiverse is intimately linked with the principles of quantum physics and cosmic inflation. To understand this, we need to journey back to the early moments of our universe. In those initial stages, a fascinating phenomenon was at play: quantum fluctuations. These are essentially tiny random changes occurring at incredibly small scales. Imagine these fluctuations as minute ripples on the surface of a calm pond. Now, these infinitesimal disturbances could have triggered different regions of the early universe to expand at varying rates. This is where cosmic inflation comes in. Cosmic inflation is the theory that soon after the Big Bang, the universe underwent a brief but immensely rapid expansion. It's like blowing up a balloon, but on a cosmic scale. Now, combine this with quantum fluctuations and you get a picture where different regions of space are inflating at different speeds. And voila, you have the potential birthplace of separate universes. But the story doesn't end there. The multiverse theory also introduces us to a concept that's even more mind-boggling: quantum foam. This is a term coined to describe the nature of space-time at its smallest scales. Rather than being smooth and continuous, space-time is imagined to be frothy, like the foam on a cappuccino with tiny bubbles constantly forming and dissolving. In this chaotic quantum foam, some bubbles could stabilize and inflate, giving rise to entirely new universes. Each of these universes could potentially have its own unique set of laws and constants. It's as though the cosmos is playing with a set of dice, where each roll might generate a different universe. So, the belief in the multiverse stems from the fundamental principles of quantum physics and cosmic inflation. And although it's a concept that seems to belong in the realm of science fiction, it's deeply rooted in scientific theory. It's like rolling a cosmic dice. Each roll could create a unique universe. But hold on, this all sounds like science fiction, right? How do we know any of this is even possible? Well, this is not a new question. The concept of the multiverse has been the subject of intense debate among scientists for years. Some of the brightest minds have grappled with this question, including the likes of Erwin Schrödinger and Max Tegmark. Schrödinger, one of the founding fathers of quantum mechanics, suggested that the very laws of quantum physics might allow for multiple histories to coexist. This idea leads us to the concept of superposition, where a particle can be in two states at once until observed. It's a bit like Schrödinger's infamous cat, both alive and dead at the same time. Now, imagine that on a cosmic scale. On the other hand, Max Tegmark, a renowned physicist from MIT, has proposed a detailed classification of potential multiverses. His classification includes 4 levels. Level 1 is a simple extension of our own universe, potentially infinite, filled with countless galaxies just like ours. Level 2 introduces the concept of different physical constants. These are separate bubble universes, each with its own unique set of laws. Then there's Level 3, which involves the many worlds interpretation of quantum mechanics. Here, each quantum event, such as a particle moving in a new direction, creates an entirely new universe. And finally, Level 4, also known as the ultimate ensemble, considers all possible mathematical structures as different universes. It's a concept that's truly mind-boggling, even for the most seasoned scientists. But what does Tegmark's classification mean for us? Simply put, it provides a framework for understanding the possible different types of multiverses that could exist. It's like a map guiding us through the potentially infinite variations of reality that could be out there, waiting to be discovered. Tegmark's classification provides a framework for understanding the possible different types of multiverses that could exist. It's a truly fascinating theory, one that continues to inspire scientists and laymen alike to question and explore the mysteries of our reality. So what does this mean for us? If the multiverse exists, it changes everything we know about reality. Let's consider the implications. If our universe is just one of many, it broadens our perspective in a way that's almost impossible to comprehend. Imagine for a moment that there are other universes out there, each with its own unique properties. It's like finding out that your hometown, which you once thought was the entire world, is just a speck on the map. There could be universes where life never emerged, perhaps due to different physical constants or laws of nature. Imagine a universe with a different gravitational constant, where stars never form, or a universe where the strong nuclear force is too weak to hold atomic nuclei together, eliminating the possibility of complex atoms and, consequently, life as we know it. Now, let's picture universes with entirely different laws of physics. It's a mind-bending concept. What would they look like? Would they follow a logical structure that we could understand, or would they be completely alien to us? But let's not stop there. What about universes where the constants are just slightly different from ours? These minute variations could lead to a completely different cosmic landscape. The speed of light might be slower, or the charge of an electron might be different. These tweaks in the fundamental properties could result in a universe where stars burn out faster, or where matter itself behaves in peculiar ways. And then there are the possibilities that truly defy our understanding. Universes with extra dimensions, or universes where time flows backwards. The prospect of such realities pushes the boundaries of our imagination and challenges our understanding of existence itself. In the grand scheme of things, this paints a picture of a cosmos far more diverse and rich than we ever imagined. It humbles us and highlights our place in the grand cosmic tapestry. The possibilities are endless, and while this might sound like science fiction, it's rooted in the principles of quantum mechanics and general relativity. Not everyone supports the multiverse theory. Some argue it's not scientifically testable, making it more philosophical than empirical. The multiverse theory, while intriguing, has its critics. A significant objection is its lack of testability. Science is grounded in the scientific method, which involves making observations, formulating a hypothesis, conducting experiments to test the hypothesis, and drawing conclusions based on the results of these experiments. But how do you test the existence of other universes that we can't observe or interact with? How do we gather empirical evidence for or against the existence of a multiverse? Critics argue that without this ability to test and falsify, the multiverse theory steps into the realm of metaphysics, the philosophical study of reality that is beyond what is perceptible to the senses. It becomes a philosophical concept rather than a scientific one, challenging the very definition of what we consider to be science. There's also the concern about the potential impact on public trust in science. Science, to many, is about concrete facts and testable theories. The multiverse theory, with its reliance on unobservable phenomena and abstract mathematics, might seem speculative or even fantastical to some. Critics worry that if science starts to look like science fiction, it could erode public confidence in scientific research. Yet, despite these criticisms, proponents of the multiverse theory argue that it is a natural consequence of our current understanding of physics. They point to the predictive power of the theory and its ability to answer fundamental questions about our universe. They argue that, while we may not be able to test for other universes directly, we might be able to detect their effects indirectly. The debate over the multiverse theory is a reflection of the vibrant, dynamic nature of science. It's a testament to our endless quest for understanding, our willingness to challenge the boundaries of knowledge, and our courage to explore ideas that push the limits of our imagination. Despite these concerns, the multiverse continues to captivate scientists and science fiction fans alike. What do you think? Legitimate science or just a wild idea? Share your thoughts below. And if you enjoyed this journey, don't forget to like and subscribe.